Hello all, I thought I'd share a project of mine called Stent. It's basically an attempt to add memory safety to C. And I'm really quite happy with it, so what I'll do is I'll jump straight into it and show you some examples of how it works, and hopefully that can facilitate some discussions. So what we've got then is basically a single header file, stent.h, and a main.c, which is pretty much just a sandbox. So it starts with the classic hello world. Now what we're going to do is we're going to create a new structure called employee, and he can have an ID. So normally you can use like malloc, calloc, things like that to instantiate it, or at least allocate the memory, and then you have to free it. But obviously you're dealing with heap memory and there's potential memory issues that can happen. So what we're going to do instead, we're going to include Stent, and because it's a single header file, I've kind of got this slight hack to basically include the implementation in one unit. So that can obviously be replaced with a library or a single C file instead. So what this will do now, it'll include stent.h, it'll also drag in the implementation in this C file, and let's see how it kind of goes about working. So we're going to basically create a new pointer effectively of type employee, and we'll call this emp, and instead of using malloc we're going to allocate and then employee. Okay, so what this is going to do is pretty much like having a struct employee pointer emp equals and then malloc employee, size of employee. So if I build this and run it, you can see that basically it says you've allocated the memory and you haven't kind of removed it. It gives you also the file and the line, and it also tells you type, which is quite nifty. But that isn't the real problem of this. I'm not too bothered about leaks these days. It's more just memory corruption and dangling points in particular. So when we actually want to free the memory, we do release, and I'll just do this. You can see it's kind of there's no warning at the end. So now then, let's actually try to create this situation that I've always encountered throughout my career with C, of having a dangling pointer. So if we have emp2 equals emp, we've released emp, but emp2 is potentially now dangling. So if I try to access ID within it, we'll run into issues. So emp2 dot ID equals 9. If I let's do it before so there's no dangling access issue. So if I basically write this, it's fine. But if I do it with my dangling pointer, remember we're releasing emp, not emp2, so emp2 is dangling. And if I build this and run it, you can see that basically it's picked that up. So employee, so the type, pointer no longer valid in main.c line 21. So that's quite nice because it basically eliminates these the issue with dangling pointers. It's not just for writing, of course. You could do that for some sort of memory protect. It also does it with reading, which I suppose you can also do some sort of memory protection. So if I do int abc equals emp2.id, you get that same kind of protection. So it immediately exits and tells you the errors happened right there and then, rather than just relying on undefined behavior or just munging the data. So that's quite cool. You feel a bit more sure about your code, let's say. So that's kind of the core bit of why I invented Stent, but it goes a bit further because it unlocks a few different things for us. So what we can also then do is a type safe vector, kind of copied from how it works in C++. So let's do this now. I'll just vector. Now we could have a vector of anything, a vector of ints, employee structures, or pointers to employees. So I'm going to do a vector of pointers and we'll call this emps, and we're going to actually instantiate it. So vector new ref employee. Classic typo. So we allocate that. We might as well leave this original emp as well. So if I build that and run it, you can see we've got basically a memory leak again. So we allocated memory, main C, line 17, and it shows you the exact type, which is quite cool. So the vector of type ref employees. So let's basically free vector now. So we do that with vector delete emps. And before we do that, I'm actually going to comment that out for now, because we're actually going to create a leak inside this vector as well. So let's push back a bunch of allocated employees, basically. So those things. So we do vector push emps, and then let's do a few of these guys. Cool. So if I build it now and run it, you can see that we've leaked the vector and we've leaked all of the employees within the vector, and you can see it's counting up with the lines as well that they're created on. So if I delete the vector, we haven't really solved much. Well, we solved one issue. the actual vector is no longer being leaked, but we still gain the leaking of the employees. So we need to do the classic, iterate through each one and delete it. So if I do employee index equals 0, employee index is less than vector size. Okay, and then in there we create a ref employee just to hold on to what we're deleting. So E equals vector at emps EI, and later on I'll show you a slightly quick way of doing this. It involves more nasty macros, but it does save a lot of typing. Okay, so we're also going to do release E. Okay, so unless I've made a typo, we run it and we don't have any leaks, and we don't have any dangling references or anything like that, which is cool. So this whole part here can basically be replaced with this for each loop, which basically says for each type employee inside emps do the stuff within this block. So we can then just do that, and it basically achieves the same thing. Okay, so that's all well and good. I'll remove this part, because what we also want to kind of cover is the idea that these vectors are type safe, which is also really important. So for example, I can't just do vector push and then push back a number. That won't work. So it basically says you can't convert an integer into this structure, and also we can't just push back if I make a struct temporarily. We also can't push this back because, as you've probably guessed, it has the it's not a pointer of anything. So these type safe vectors are pretty handy. We're not just dealing with kind of void pointers or anything being cast to a character pointer or anything like that. Now, I would say this is pretty safe. There's some overhead, so effectively, without going into too much detail, you've kind of got this lookup table where you delete the original bit of data, but you still have to go through this lookup table whenever you use this kind of situation. And that's the equivalent of having a normal pointer and then using the arrow. The difference is this macro first checks to make sure the actual value is valid within the lookup table, then it goes through and it pulls through the actual pointer like normal. So there is overhead, but the good thing is this only needs to be done through the debug build. So once we've debugged it and it doesn't flag up any memory issues, then there isn't really so much need to keep the actual stent part in there. So for there, you can basically just disable it. Obviously you probably want to do this through like CMake or your makefile, so it disables stent through for every unit, otherwise you'll run into some weird issues. So effectively, now that stent's disabled, you still get some of the usefulness, but it doesn't have the memory debugger, so you don't have the overhead. And to be honest, that's pretty much it. So Stent is there to not really replace, the high performance part of your C, certainly not, but it's the part to, it can replace the part that you probably consider using a different language for, like a scripting layer or Java, because those by default are potentially safer. Whereas this, it offers you a good amount of safety, so it could be a good compromise. Anyway, that's it from me. Thanks for listening, guys.